Hello everyone and welcome back. In this video, I'm going to go over the second problem dealing with constant volume calorimetry, which again is dealing with a bomb calorimeter. In this problem, we're going to do the combustion of toluene, C7H8, and the combustion of toluene, we are given the delta E of the reaction is negative 3.91 times 10 to the third kilojoules per mole. We're given 1.55 grams of the toluene. That's going to be burned in the bomb calorimeter, so that's going to release a certain amount of heat, which is here, per mole. So we're going to have to convert this to moles. And also we have the initial temperature and the final temperature, and we're being asked to find the calorimeter constant. So we're going to use this equation again, where we've got the Q of the calorimeter, the amount of heat picked up by the calorimeter is the specific heat of the calorimeter multiplied by the change in temperature. The amount of heat that's picked up by the calorimeter is going to be Q of the calorimeter, if you remember, is going to be equal but opposite to Q of the reaction. So we need to figure out what the Q of the reaction is. So what we need to do is they gave us the delta E of the reaction in kilojoules per mole. And again, you notice that the energy unit is divided by moles. So to get the energy unit by itself from the delta E of the reaction, we're going to need to multiply by moles. So we need to convert 1.55 grams to moles. So if we do 1.55 grams of the toluene, which is C7H8, over 1, we're going to calculate the molar mass, and that's going to be, let's see, so 12.011 times, what is it, 7, and then we're going to add to that 8 times 1.008 equals, and so we get 92. So 92.141 grams of the toluene over 1 mole of the toluene, C7H8. And that's going to be equal to, so 1.55 divided by equals, and so that's going to give us 0.016822 moles of the toluene, C7H8. And again, we got to keep track of sig figs. So we have 3 here, we have 5 here, so least number is 3. So that 8 is going to be the last sig fig for this calculation. So this is the moles that we burned. So then what we could do is we could take that delta E, so delta E of the reaction is equal to negative 3.91 times 10 to the third kilojoules per mole. And we're going to multiply that by the number of moles that we got here, 0.016822 moles of our toluene, C7H8. So we multiply those together times 3.91 times 10 to the third equals, and we get negative 65.77419, and this is going to be in kilojoules. So this is the amount of heat evolved from the reaction in kilojoules. And again, keeping track of our sig figs, we had 3 here, and we have 3 here. So we're going to have 3 here. So we're going to cut it off there, but we're not done with our calculation because we're being asked for the calorimetry constant. So now we can use this equation plus the change in temperature and the Q of the calorimeter, which is going to be equal but opposite to this number. So the Q of the calorimeter is going to be the same number, but it's going to be positive because it is picking up this energy from the reaction. So this is kilojoules there. And so now we can plug this in. So we have positive 65.77419 kilojoules is equal to the calorimeter constant, or the specific heat of the calorimeter, multiplied by the change in temperature, which is final minus initial. So you have 37.57 degrees Celsius for the final temperature minus the initial temperature, which is 23.12 degrees Celsius. And so you can take this number and divide it by the difference here. So we're going to divide it by, so we have 37.57 minus 23.12 equals, and notice that we have degrees Celsius. So when we divide this, we're going to get 4.5518 kilojoules per degree Celsius, which is what you would expect for the units of specific heat of a calorimeter. And so again, we're looking at the decimal places here. We have two decimal places. So when you subtract these, 37.57 minus 23.12, you get equals, and you get 14. So the difference is 14.45 degrees Celsius. So we have 4 sig figs here. You had 3 sig figs here, if I remember correctly. So 3 sig figs. So your final answer should be in 3 sig figs. So that's going to be the answer to this problem. I hope you found this simple and easy and understandable. If you like this video, share this video with your friends. Hit the notification bell to be notified for more videos. Hit the subscribe button and make a comment in the comment section. Let me know if there's any questions you want me to answer. Thank you for joining me, and have a good day. See you next time.